WarsawJS.
All right, so as a starting remark, I'd like to thank my predecessors because I'm getting hungry now from all the global promos. So, yeah, without further ado, I'm Robert, and I've been here for quite a few times, but the last 2 years have been demanding, let's say. So it's good to be back, guys. And the topic of today's talk is sessions versus tokens. And first, a quick poll: who in their programming career has used the session mechanism to preserve some info about the user? Okay, sessions, team sessions. Okay, that's great. And who has used something called JSON Web Token, or JWT for short? Okay, well, that's nice. So this could be the first time that I'm seeing team tokens, even more numerous than team sessions. And this has been a contentious topic as of late. And I see articles popping up everywhere, especially on the Node.js Reddit. Oh, did you know there's a Node.js subreddit? So there you have it. So I'm seeing all kinds of articles, tutorials, and videos that show in varying degrees of detail how to use JSON Web Token for different kinds of purposes. And one of these is maintaining user login state. So basically, when you log in, and we're going to get to that, they function as something of a session. So before we dive in, here's some background info about me. I've been programming in Node.js for nearly a decade now, it looks like, so hooray. And I currently work for @Tonos as a senior developer. You might have guessed the position name. And before you ask, @Tonos, first of all, is one of the sponsors of today's fine gathering, but also it's a 360-degree it's a 360-degree marketplace for digital audio advertising. So whether you are a publisher, like a radio station owner, a audiobook publisher, or maybe if you own a podcast and you're looking to monetize your content, so basically insert ads and earn a lot of money, then we're your guys. But also, if you're an advertiser that's looking for a venue to present your ads, to basically you need airtime to present so that listeners can hear your ad, then we're also someone you could contact and basically pay us. so that's it. And as you can see, there's many parties involved in a transaction that's about ads. So you've got advertisers who provide the ads and basically pay money for playouts. There's publishers who own the radio stations, games, and all kinds of stuff, and they're different, right? They're two opposite sides. There's a marketplace, which is us in the middle, and this is going to be significant today because we're going to be talking a lot about authorization, or how these users differ from one another, and how their permissions are different in a complex business system. So there's also a fun note: we're currently hiring. So if you're looking for a job that involves a lot of backend, some front end as well, that's maybe your day. All right, so there comes a time in the life of every developer when you've created some basic routes in the backend using Express.js, Fastify, or basically go to town. Now you have a nice login screen with a big green inviting button that says log me in. But what now? You're probably looking for a way to persist some, first obviously to check the username, password, and whatever kind of authentication you may be using. But the end result should be that we keep the user logged in so they don't need to repeat this process at every step of the way, which would be ridiculous, frankly. This is 2022, right? But also, we need to make some assertions about the user, what they can and cannot do, and especially in terms of in enterprise systems, we would like to be able to show or hide or enable or disable some subsets of the system's total functionality. So you've got slightly different options for the system administrator or operators, and you've got different options as well for advertisers who, frankly, do different stuff than publishers. Like publishers have a listing of the radio stations or maybe the audiobooks and the revenue numbers for the month. But on the other hand, advertisers have the list of ads and how well their marketing campaigns are doing. So as we can see, if even if we had some separate back offices for the two kinds of users, for the two classes of users, then you still need some ways to let the one in, but not the other way, not the other group of guys. So, so let's take a moment to think about authentication and authorization for a while. These two words sound similar, but just a quick reminder. So authentication in the context of user management, because there's different kinds of authentication, like in crypto systems, but here it's just about proving who you are. So basically providing some kind of secret credentials that only you and the service provider know, like a user password pair, or maybe it's a FIDO token or something like that. But the end result is that you have proven that you are who you claim to be. And the other point being authorization, which is controlling access to system resources. So basically, what usually happens is you authenticate once or not so often, and you authorize all the time. So the system is going to be basically looking at who you are and what you can do every step of the way. And this is depicted here. So you've got, let's see if I can make this disappear. Yeah, okay. So you've got a user whose first step with interacting with the system, obviously if this is a system that requires authentication, is providing some set of credentials like a user password pair. Then we have authentication logic. So the backend needs to establish that the password actually matches what's stored. And then you're provided with some kind of secret so that you don't have to send the user password all the time. So usually this secret in traditional web apps has been a session ID or some kind of cookie that you can then resend back. So this is step 2. You get something from the server. Here's a fun fact. If you're using HTTP basic auth, so the oldest way of authentication that's available on the web, and you really probably shouldn't be using that, there's only step 1. So at every request with HTTP basic auth, you're just sending the user and the password in a header. So it's actually pretty clunky today. For instance, there's no way to log out because the browsers typically don't provide that. But just keep this in mind. If you are using HTTP basic auth, you're stuck at step 1. So now that you've got a secret, such as a session ID, you are going to keep using it at every step of the way. So you do some stuff like, I don't know, list marketing campaigns, start a new marketing campaign, see how well you're doing monetary-wise, and so on. So so then you just keep interacting with the system, but you resend this secret. So this secret usually will be a cookie, and it should be a cookie. So every time somebody tells you that it should be a local storage or session storage or something else, just say no to that. Why? Because local storage is accessible from the front end, and if your front end does get compromised, for instance, by cross-site scripting, by reflected cross-site scripting, or by a plethora of different vulnerabilities that can happen on the front-end side, then your credentials, your secret, which can be a session ID but also JWT, can leak. So basically, there's only one right way to do sessions and client-side secrets, and is HTTP-only cookies served over TLS or SSL. So when you've got a cookie like that, the front end won't see it, but it doesn't matter because it still gets appended at step 3 and at step 4 automatically. So when you do requests to the web app, your browser just includes the header with the cookie, right? So now that we've gone through that and we know what the authorization steps, basically 3 and 4, and what precedes it, so authentication steps 1 and 2 are, let's take a look at what the secret actually can look like. So what you get after you have logged in could be a cookie with a session ID. Now, this looks like an opaque string, and for a good reason. It is an opaque string and doesn't tell you much. So who can tell me some property of the string that's easily visible? Like, what can you tell me about this mess here? All right, it's got 5 parts. It's yeah, it's a UUID. I'll add that it's UUID version 4. Yeah, that's correct. And what property do they have? Yeah, it's unique. And can I guess it in advance? It's not deterministic. Yeah, it's not deterministic. It's random and it's hard to guess. So, for instance, if there's a colleague here sitting with a laptop, hey, you're probably logged into Facebook or something else, right? And if I were to guess your current session ID that you got from Facebook, I would not be able to do it just from looking at you, checking what time of day it is, and so on. So this is hard to guess. It needs high entropy. So for instance, for UID4, this is 128 bits. So it's pretty secure from a cryptographic perspective. You cannot forge, you cannot easily forge it. You cannot guess it. So if you were to guess it, you could impersonate somebody, but you probably can't because it's so random, right? But still, as we've said, this is opaque and it doesn't really tell us anything. So if we are using this for authorization, so for if-else decisions on the backend, we need some way of establishing is this session, does this session belong to an advertiser? Is the system admin? Should they be able to do or nothing? Maybe some subset of the operations that our system allows, right? So every time we get a session ID, we need to resolve it using some kind of session database. And this might seem obvious to you, but we're going to look at some architectural diagrams later and wonder about some trade-offs of different architectural solutions. And we're going to see some advantages and drawbacks of this. So just keep this in mind. We need some kind of database. It might be memory, it might be a map in Node.js, it might be, I don't know, Redis, MongoDB or something, but it still needs to exist in some place, right? And option B is what you can see here. Who recognizes this screenshot from somewhere? All right, so this is the JWT debugger on jwt.io. It's a helpful little website that lets you debug JSON Web Tokens, so see what's inside. And don't worry if this seems too small. It is too small for now, but we're going to pick inside, so there's going to be a zoom in a while. But what matters is on the left, in the encoded portion, you can see the JSON Web Token. So it has three parts. The red one, which goes first, is the header, which is just some metadata about the token, so it's understandable to machines. Then there's the payload, which is the interesting part that we're going to look at right now. And there's some signature that makes it trusted. So it's cryptographically signed. So if you send it back to the client as a cookie, and then the client sends the JSON Web Token back, but having modified it, saying I am an admin equals true, then you can easily detect it because it's non-malleable. So this means that if any change in the payload will be detected and rejected by the server. So you can easily say this ticket, this JSON Web Token is authentic, or it's not authentic, it has been tampered with. So this means that if you see something like this going back to your server, you know that it is the server who has generated it. So these assertions, this user info, you know it to be true because you verify it at each request. And this actually does end up in the cookie, so you can see it in plain text if you decode the token. And what this means is you can safely say that this belongs to a subject or a person holding the JSON Web Token, who's Alex at adsexample.com, and his role in the system is an advertiser. So he should be able to perform advertisory things, whatever it is they do on the backend, right? There's also some timestamp fields which determine when it expires, and this is going to be an important point. So just remember that there's like sessions, they're not forever. It expires at some point in the future, and you might be able to hold on to a JSON Web Token, but not forever, but only for, I don't know, some minutes, some hours. It all depends on the expiration field. All right, so let's see how the two kinds of authorizations differ. The first one at the top is the user wielding a session ID that they have received from a login process. So when we authorize, we ask, is this user, for instance, an advertiser, because they're trying to start a new advertising campaign, they want some ads played on some radio. So based on the session ID, we need to go to some kind of session database where the details of the logged in user are stored. So we turn the ID into some set of claims about some assertions about the user, like they can do advertisory stuff, they're an advertiser, they should be able to access this area of the system. Sometimes even that's not enough, because if you aren't careful when developing your session middleware or your login process, you might not save this info in the session. So if you don't persist a flag that says this is an advertiser, you might still need a round trip to the database. So first you resolve the user ID based on session ID. So it goes session ID resolves to user ID, but then the user ID still needs to be resolved to this user's role or access level, permission level, etc. So you can see there's a bit of back and forth involved between the application, which is basically your Node.js process, and some database or even databases. This is a round trip, and obviously it does cost time. Also, you also need to manage a database, so it costs you money. You probably need to pay for some, I don't know, license, seat, or a VM that's serving that, or I don't know, credits on AWS. But still, it's not negligible, right? And then you have token-based authorization here at the bottom, and the difference is the user already wields a trusted token, and it already says everything that you need to know. So in your application, you can just take the token, having verified it, and have an if that says, if this is an advertiser, then yeah, just let the guy run some ads on our network, or just if this is a publisher, then they should be able to stop the transmission for radio and replace it with some music because it's undergoing maintenance. So there is no database involved here, and this seems like a huge boon to everyone suddenly. And this is also, I think, part of why the JWT popularity has been growing. So you just give the user a token, and use the token, and look, there's no database, no costs, the performance seems higher, right? So let's look at the database request, which is the second arrow on the right, the top. This is a round trip, so it could take several handful of milliseconds. It could be slow, but it does happen. And where some see runtime costs, others see opportunity. And this query that happens actually needs to find a row or a record or maybe a document if it's MongoDB that's associated with the session ID. So it does a lookup by some key, by some index of the session. But the important thing is it actually has to do the lookup and find the record. So this is an opportunity if you are trying to, for instance, log the user out quickly or to lock them out of the system, to delete this record. And this can create something that's called a closed loop system, where if you delete a record from database, you immediately lock out all users of the record or of the credential out of the system. So in some circles, it might be necessary that you are able to actually flip the switch and break the circuit. The user is disconnected from now on from the system until they can re-authenticate. And this actually is important from a security incident response point of view, because closed loop systems are a thing. And in some industries, you might actually get a review question from the security guys that come from some exotic countries that ask, is this a closed loop system? And then you need to prove that. So this request, it does need to happen. And now that we've looked at some architectural stuff very broadly, let's consider some pros and cons of the two systems, of the two solutions that we've described. So instant validation, or the creation of a closed loop system for sessions, is a huge plus, right? But this comes at the cost of latency. So this database request that enables the discovery of expired sessions, of deleted sessions, which were forcibly terminated, comes at the cost of latency and some load for your infrastructure. So it costs you time and money, right? Then, as a plus for sessions, you have listability. So you can actually come into the system, have a user panel that says, how many times have I logged in today? Then you're in Warsaw, right? And you go and you see some users from, I don't know, Russia, and hey, that's not me, wait a second. So you have an opportunity to discover attackers and just catch them red-handed. So with JSON Web Tokens, there's no database, so there's no place to discover this kind of entry. It just doesn't exist. Sure, maybe there are server logs, but you're a user and you're not the server admin. So you have really no way to refer to fail to ban logs or something like that and just discover this for yourself. So there's no tool that you're given as a user or even a system operator to deal with any kind of suspicious activity that you're not sure about. However, in some distributed systems, which are composed of services in a service-oriented architecture, or maybe with a microservice kind of product, this creates a coupling to a central DB. So the DB needs to contain some kind of record, some kind of, I don't know, document. If it's MongoDB, it needs to have some kind of schema, some field names. And imagine if I told you today that there's a service running on Node.js that uses some Express-session, and there's some guys trying to integrate with session DB, so they would like single sign-on, but they're using Java or PHP. And let's see how well that works out, right? So this is not a great situation to be in. And the thing is, the coupling that we've introduced can be unacceptable in some situations. So for some systems that you're developing, well, first of all, obviously you should consider whether you need microservices or not, but this is a whole different discussion. But when you have gone down this route, there's inherent coupling that you get with session DBs. So you might not be able to use sessions as they are. But last but not least, an advantage of using plain old sessions is there's a database record. So there's a natural tendency to put some extra data. So for instance, a shopping cart is a good example, or the last seen, last viewed screens, last viewed products, I don't know, your favorite stations in the session and so on. So you know, if you imagine how you would build a shopping cart without sessions or without some auxiliary state, it's not that obvious, right? I mean, we're going to get to that in a while, but it just doesn't offer you the default place to put everything in, which is session data. But this comes at a cost. So let me ask you a question. Has this ever happened to you? You're in a web store of any kind, you're buying some products, and you click add to cart, and then you click it again fast. And then you go to your cart to inspect how many products you've added. You want 2 of the item, but there's only 1 in there. So does this sound familiar? This is an example of a session race condition, because sessions, and this is not the main topic today, but we're still going to pay, I don't know, 15 seconds to it. So sessions work like this. They load your session state at the beginning of the request handler. Then you're allowed to modify something in the session, and they write it back, replacing the previous session state. This is known as a read, modify, write loop. And this is like the most widespread generator of all kinds of race conditions. Right, you're cruising for race conditions. So just something to keep this in mind, and we're going to see about a fix in a moment. So first of all, we've mentioned some drawbacks regarding sessions, and those were purported to be poor performance. But did you know that you may be using sessions needlessly for some routes? Like, let's say you have an app, and this app involves some API, but also some images, some style sheets, and so on. And it is possible that if you're not careful when deploying your session middleware, like Express session, Festify session, etc., your session middleware might be loading the data and maybe even saving the data needlessly at every request. So try and identify some public resources like style sheets, or basically anything that you're not already hosting on a CDN but directly from your application, and just exempt it from the session mechanism. And there's one item that's often overlooked, and this is the Fev icon. The Fev icon is a performance killer in many ways, but sessions are one of them. Now, if your database is not up to par for storing sessions, just make it faster. So invest in a database that's less loaded. Maybe separate the session database from our main database, or maybe just make it Redis or Memcache, or maybe MongoDB, but it's it's not as fast as in-memory DB. Make it shardable, because we've seen that the session IDs are actually pretty random. So it's easy to get a uniform distribution between shards, so you can scale it. Now, also stop storing app state in sessions. I know this seems easier said than done, but actually what you should be doing if you want to avoid race conditions, like I've told with the button, is store a reference. So you store a reference to a shopping cart, and then you model a shopping cart using some concurrency primitives like transactions. Yeah. All right. So here are some pros and cons of JSON Web Tokens, and we are nearing the end. Don't worry. And okay. So there's no infrastructure, but also you cannot force a closed loop system. They are obvious to scale because you just scale the app, because it's the app that's processing the entirety of the token. There's no database. but it's harder to keep changing data, which you can do in local storage. And actually, this is what you might be able to do. So just use local storage for the client-side card, and you should be fine. Also, discuss token expiry times, because using too long of a token can be dangerous, and using too short of a token may be annoying to your users. So there's also a technique called refresh tokens, and this is important because you might get two kinds of tokens. You get a longer-lived token that you can use to obtain a shorter-lived token, and then you just iterate. So every time you run out, the client needs to know, oh, I've run out of time, like I did just. But so I need to obtain a new access token. This works, but obviously you need a way to revoke a refresh token. So then you build a database where you store the revoked refresh token IDs. And if you look at it, you have just reinvented sessions, maybe. So what if we could get best of both worlds? What if we could do access plus refresh tokens, but also maintain a database where we actually keep track of the issued refresh tokens and treat them like sessions. So we get a listing of the refresh tokens, and you have a revoke button that you can use. So obviously this is a non-zero time where you have no control. So for instance, let's say you've issued a 5-minute access token. The attackers are using it actively, but for these 5 minutes, your hands are tied. But after this, the client needs to hit up the refresh database, and this database says, sorry, but we're not serving you anymore. So this doesn't let you create a closed loop system, but you can approximate it with some time lag. So this is important to keep in mind, right? And no matter what you choose, you should be starting with some kind of domain model that actually lets you ask some questions, but not of the cookie. So you should not be referring to cookies or this with tokens themselves or to the database, but you should abstract away some methods that let you ask, is this an admin, is this an advertiser, and hide your implementation. So this lets you refactor later and start from the simplest solution. So you might be able to start with sessions, but progress to JWT or refresh tokens, etc. So this is the summary. Here are some rules of thumb. Sessions might be fine if you're just starting out. They probably are fine, to be honest. But if you're using JWT, let it be for a good reason. So for instance, if you think that you're going to be hitting the refresh token database quite rarely, so for instance, only for 0.01% of the requests, it's a very good idea to actually issue access tokens, use them excessively, and then just let the API refresh when it needs to. Maybe it won't need to, because maybe it's doing some kind of bulk operation that it just needs 5 minutes for, and by the time the refresh token has expired, the API client has done its job. So this is a great use case for JWTs. So also when using microservices or systems where there's some kind of federated identity, especially like OAuth, OpenID Connect, or so on, then you may be forced to use JWT, but also know what you're losing by this. So you cannot create a closed loop system. So this is important to know that you have sacrificed something by building a more complex system, actually. Also, invest in abstractions early, because it might come in useful later when you're growing. And also know how to cut off access. So know where the big red button is and how long from the moment you press it until it actually takes effect. So when do the bad guys stop interacting with your system? This is just note this number down and look at it every once in a while. It might surprise you. Okay, so here are some third-party solutions that you should be aware of. First is Keycloak, which is a federated identity platform. So basically, it offers single sign-on, single user account, but also, before you ask, all these are hybrids. So they actually give you access tokens, refresh tokens, but also they do emulate sessions. So no matter if you choose Keycloak, Auth0, or something called Super Tokens, which is developing rapidly, you're getting a hybrid. So just know that you are getting a refresh token. There's some lag time by the time the access token expires, and also there's gonna be a panel that lets you expire refresh tokens, so sessions, so-called here. But this is basically it. So know what you're buying. You're buying a hybrid solution, And maybe it could be simpler, and maybe you're served better by a plain old session system. I highly recommend reading the super tokens documentation because they're pretty new, but their docs actually show you some helpful arrows and architectural diagrams. So if you're trying to learn about not how much it costs, but actually how it works under the hood, then super tokens is great because they offer actual learning material in their marketing portfolio. So here are the closing remarks or the takeaways. You're responsible for authorization, and even if you outsource authentication to a third-party provider to federate identity or something, you're still responsible for authorizing, and you're still buying some kind of trade-off. Pick the right tool for the job. Maybe start with just sessions and don't get into the hype early. And actually talk to security or incident response people. If you don't have any dedicated security or incident response people, that might be you someday. So just think about what you are going to do when the bad guys get in. And here are some links. You're obviously going to get this presentation later. If you prefer long-form articles to read rather than listen to, that's a great article by Evert Pot about why JWT and just using it blindly is a bad default. And also there's some links to the products and some tools that we mentioned earlier. So questions?
Any questions? We got time for 3 questions.
Thanks. Question from me. Do you think the JWT is a good pick for standard SPA? Is there a response for that question? The simple one.
Right. So
because there is a lot of discussions about that, and it's not always.
So the answer is going to be short, and it's a no. It isn't a good choice if you're just starting out, unless you have a compelling reason to do that. For instance, if you're using Firebase auth, then obviously you're going to use some form of token. But if at all possible, strive for sessions because it's obvious how to make a user panel or how to log everyone out in case what happens with the fan. So yeah, if possible, just use the simplest thing out there.
Yeah, thank you.
Really wonderful talk. I think this is one of the rare moments when I will say that you had too few slides, because your presentation was full of technical details. It might have been boring for young adepts, but really it was wonderful talk. I have 2 questions. Okay. Okay.
At least it's not more of a comment, right?
Okay, so I will get rid of first question. Yeah. Second question. You have shown us JWT and Code.io. This question is not referred to your talk. Yeah.
You
First question, which I'm skipping, is referred, but do you know on the left-hand side we've got colored input,
yep.
And my question is, do you know how it's done? Have you reverse engineered that?
You mean the page?
Yeah, no, like this coloring that this is like text area which is different color. It has different stylings for dot separated tokens.
Well, as you might have noticed, I'm more of a backend guy, so I barely know what a text area is.
Okay, thank you. But you really wonderful talk. Thank you very much.